end of each one of the statements, and I'm going to run them. So does it look good? Yep. So I got a course, I got membership, 2 foreign keys, and I got user. So that all looks good. Okay, so now we're going to have to insert some data in. And we're going to insert from the outside in. And so we're going to just put the name and email. The ID will be automatically assigned for the users. And we're going to do the same thing. And the ID and the courses will be automatically assigned. So let me just grab all this stuff. Go into SQL. That has the semicolons at the end already for me. Thank you very much. Now I'm going to run it. And if I take a look at my data, now I've got primary keys for the courses, and I've got primary keys for the users, and I've got nothing in the membership table. And I of course have to remember what these values are, because Jane is 1 and Ed is 2 and Sue is 3, right? And Python is 1, SQL is 2, is 3. And so when I go into membership, I've got 2 foreign keys here and a role, and they just have to be for the course person combination. And so it's a little tricky to figure all this stuff out. But again, these are just numbers, and if you look at these numbers, user ID, course ID, role, well, user ID 1 is in course 1, user ID is in course as the teacher, user ID 2 is in course 1 as the student, etc., etc., etc. So I'm making these connections by just putting these little numbers in, and once again, conveniently, I have all my semicolons perfectly in place. So I go to SQL, and then I run that, and then I take and I look at my membership data, and there it is. So 2 foreign keys and a bit of data modeled at the connection. That's the way we say that. The role is modeled at the connection. So now we build all this stuff up, we can write some queries that take a look at this. And so what we're going to do is we're going to look at who's in what course and what role are they, and we're going to sort this in a nice way. So let's just take a quick look at the code we're writing. We're going to do a select from 3 tables: the username, the member role, the course title. So in effect, we're not showing any of the foreign keys or the primary keys. We're going to go from the user table, join to the member table, join to the course table. This is pretty easy to write. You know there are 3 tables you want to go across. The on clause is also very easy to write, right? The on clause models each of these connections, where the member's user ID is equal to the user's ID, and where the member's course ID is equal to the course ID. So we're going to concatenate all 3 of these tables together, but we're going to only keep rows where it matters. Now that this role doesn't participate, but we're going to print that out. And we're going to order it by the course title first, and then the member role second, and the name third. And so let's run that. So we've reconnected it. So Ed's the teacher of the PHP class, Sue is the student in the PHP class, Jane is the teacher in the Python class, Ed's a student, and Sue are students in the Python class. Ed's the teacher in the SQL class, and Jane is the student in the SQL class. And so we have many people there are many students in many classes there, and so we have modeled that, but we model that with this sort of table. And if you look at a piece of software that I've written called Sugi, which is a standalone learning management system that's built with learning tools, you will see in anything we're in membership where we have a user table, we have a context which is also the course table, and then we have a membership table, and you look, here's these foreign keys. It's kind of like that's the many side, that's the one side, many to one, and so this, this is now in effect a many to many between these two, but then it's modeled as a series of many to one relationships. And you see this all the time in all kinds of things where membership or other kinds of things are necessary, many to one, or many to many. So, with all that, there's so much to learn. It's both easy and complex at the same time. It's easy when someone shows you how to do it, but at some point you will learn how to build database models and you realize, oh, it wasn't so bad. It takes a while to get used to them. This really just is a quick walk. But the bottom line is what we just did seems like it was, wow, that's nice. Do you really have to do that? And the answer is, if you're going to scale at all, you absolutely have to, because you simply can't read and write data sequentially. You can't read through, update one little piece of data in a file by reading all the way through and then writing a new copy of the file. That could take seconds. And in a system like an online system, you get 1/100th of a second to do something like that. And the databases make it so that happens in 1,000th of a second. So ultimately, you simply have to take advantage of this. You just can't, if you're going to modify data, you can read data from flat files, but even if you're going to read a lot of data, if it's big, it slows down terribly. So it might seem like there's a trade-off that you could debate whether this is worth it, but if you're going to deal with a lot of data, you've got no choice. It's really not as much a trade-off as you think. So this has been a quick romp through databases. We talked a little bit about indexes. There are constraints. We talked a little bit the not null stuff. We've talked about that. Uniqueness, that's a constraint. Another whole area is what's called transactions, and that's the locking of little areas, so you can read an area, then lock it, and then update it to make sure no one else reads it. And so they make sure they either get the version before you looked at it, or before you change it, or after you change it. And so that's how you make sure that you can't do things having to do with bank account balances and get yourself in trouble. So these are a lot of SQL. It's really fascinating. SQL is a fascinating thing to use and learn and performance tune and enjoy. So relational databases are cool. This gets us started. The big thing is, don't allow replication vertically of string data. Pull that out into a separate table, establish a primary key, and then have foreign keys that point to that primary key. It is not just how much data you store. It's sort of a compression way, as a way of compressing data. You might think strings take no data, but they do. Numbers take a lot less data, and it's both how much data that's stored, but also how much data has to be scanned. And that way joins work. That's part of the magic of why Oracle's such a successful company. It's a bit of art form, and it's something that you can work your whole life and always get better at.
Hello and welcome to our code walkthrough on the roster code. So the learning objective of this is to do a many-to-many table. And so the idea is that we're going to, just like we talked about in lecture, we're going to have a set of users, we're going to have a set of courses, and then we're going to have a connector table or a many-to-many table that basically has two foreign keys. So we are going to use the integer not null primary key auto increment unique as the way to get auto assignment of the primary keys in the user table and the course table. And then we're going to say that the name, which is like a logical key, and then the course title, we're going to mark those as unique. And we're going to take advantage of that in a moment. And so you'll see how we take advantage of that. So what unique means is if you try to insert the same string into this column, like Chuck twice, then it's going to fail the second time because it's going to refuse to create a new record. And so if we just kind of take a look, we're going to get our roster data from this sample JSON, which is just an array of arrays. And this is the person's name, the class that they're in, and whether they are a teacher or a student. And so we're going to read that. So we need the JSON library and the SQLite library. We make a database connection and we get a cursor. The cursor is the kind of more like the file handle. You send SQL commands to the cursor and then you read the cursor to get the data back. The connection can create more than one cursor so you can have more than one set of commands. But the cursor is generally like the file handle to the database server. And we are going to execute a big script, and you'll notice this is a triple quoted string that goes all the way down to here. And so some people would just give this to you in a text file and have you cut and paste this and then go run that in your SQLite browser to create them. But that's okay, because what we're going to do is we're going to set this up. It will either reconnect to existing file name rosterdb.sqlite, and if I look where I'm at, I do an ls, we find that that file is not there. So the first time I run it, it's going to create it. But I want this to start fresh every time, so I'm going to wipe out the tables if they exist. That way you can run it over and over and over again in case you make a mistake here. Now I don't have a mistake, or hopefully I don't have a mistake on this. So we're going to drop 3 tables, and we're going to create 3 tables. And